So let's start with 425 divided by 3. So how many times does 3 go into 4? Once. And then we multiply it back. 1 times 3 is 3. What do we do with that 3? Subtract it. Subtract the 3. Gets us 1. What number do we use next? The 2. Bring down the 2. That's an easy one. 4 times 3 is 12. Subtract it again. We get 0. Then we use the 5. See, 3 goes into 5 one time. Multiply it. Subtract it. Now, here's why I wanted to work this problem. What do I do with the 2, or what is the 2? You did like 3 different things with it, so that's where. Go ahead.
Put a decimal and then put a 0.
Okay. Yeah. You can do the 0.000 and just keep going until you figure out it repeats or it terminates or whatever. But yes, adding decimals is one of the things you can do. What else can you do? Do you remember? Remainder. That's what you did first. That was like the easiest thing. You just said, oh, there's 2 leftovers. So if I had 425 marbles and I wanted to put them in groups of 3, I'd have 141 groups and 2 marbles left over. Is everything okay?
Yeah, 6th grade flashbacks.
Yeah, right? Remainder. It's all like that was the first thing you did. You said, oh, there's 2 left over. And then later you learned about adding decimals, and then probably later than that you figured out you could do 2 over 3. Real fancy. But for now we're just going to stick with the remainder. What would it mean if remainder was 0? It means there's no remainder. What would that mean about 3 and 425? I'm looking for a word that's on the page somewhere. If the remainder is 0, then 3 is a blank of 425. Factor. 3 is a factor of 425. I mean, it's not, but if the remainder was 0, then what we divided by is a factor of what we were dividing. Dividend and all the other fancy words. Okay, but that remainder 0 thing, remainder 0 tells me it's a factor. That's kind of the main point of today. If the remainder is 0, then you've got a factor. It was true when we were in 6th grade or whenever we were long dividing with remainders. And it's true today when we're dividing with much bigger things. Okay, the procedure today is not like that, but there's going to be some similarities that you might catch. Synthetic division is a procedure to divide a polynomial by a binomial. Look at our examples here. There's our polynomial. There's the binomial. Using coefficients of the dividend and the value of r in the divisor x minus r. That's a lot of words. Let's just do this. Synthetic division is really pretty easy. My calculus students had to be reminded how to do it, but once I showed them one, they're like, oh yeah, that's easy stuff. We remember that. You start by using these coefficients, but just the coefficients. So don't write down x cubed and x squared and x. You're just going to write down 2, negative 5, 5, negative 2. So coefficients. And then this part is going to look funny, maybe. When we divide, we use that little house thing. Every year I try to remember to look up the name of that. If that house has a special name, I don't know if it does or not. This one kind of has the same type of thing, but it feels like it's upside down. So you're going to put it like that. Be careful there. Leave a row there because we're going to put some numbers there. So kind of an upside down house thing. It's going to look kind of like a matrix when we're done. We're going to have a whole bunch of numbers, and like what to do with those numbers is kind of the point of today. Okay, and the value of r in the divisor x minus r. That sounds really complicated. Phrase it this way. If x minus 1 is a factor, then what is the root? What is the solution? This is what we just did yesterday, right? If x minus 1 was one of the factors, then what was your next step if it was a solved problem? X. You'd set it equal to 0. What would you get for x in this problem? 1. And so we change the sign for the number that goes out there. Change the sign. Just like you always change the sign when you go from a factor to a root. Sign changes. Same thing here. Change that sign.
So these two were like setting the binomial equal to 0 and then using whatever x equals.
Correct. So you'd say x minus 1 equals 0, so x equals 1, so we'll use 1. Nobody ever shows that step because it's pretty easy to just change the sign. Okay, to get started, and it's the easiest step, but sometimes people forget how to get started. You just copy down the 2. Just bring down the 2. Here comes the fun part. We're going to multiply. Let's see how to label that. I'm going to put an M on that. We're going to multiply by the 1. So 1 times 2 is 2. And then we're going to add. These are lined up nicely for us to add. Negative 5 plus 2 is negative 3. And then we just keep repeating that till we get to the end. So we'll multiply. 1 times negative 3 is negative 3. And then we add and we get 2. And we multiply and get 2. And add and get 0.
Why is it multiply and then just switching it to the other side?
I mean, it's related to what we did up here where we would multiply it back.
I thought it was something like important to know.
No, it's just, that's the process. You just got to know the process. So you have to know the process and you have to know what it means, what the answer means. So first job is the process, copy down the 2, and then multiply, add, multiply, add, multiply, add until you get to the end. Now, a couple of things about our answer here, because, Ben mentioned matrix earlier. It's not officially a matrix, but I get it. It's an array of numbers. It's a set of numbers, and what does it all mean? But part of what it means, this last number is always the remainder. Last number is always the remainder. And for this particular problem, because r equals 0, that means x minus 1 is a factor. So if you get a remainder 0, that means you found a factor. These numbers kind of have a funny name. We started with coefficients. The 2, negative 5, 5, negative 2, those are coefficients. These are also coefficients, but we divided by x, so they're down a power. We started with x cubed, we divided by x, so we're down to x squared, and that down part is why they're called the depressed coefficients. Sad, right? Depressed coefficients. We don't use that term often, but if you're trying to say, my new numbers, how do you say those are the depressed coefficients?
Why do you need to know it's depressed?
I mean, you don't really need to know that that's what they're called, but so that we can call them something when it's time to talk about them, the depressed coefficients. Haley? Why they're depressed coefficients? That's a good question. We started with 2x cubed plus a bunch of other stuff, and we divided by x minus 1. Well, x cubed over x, like just looking at those lead terms there, that's 2x squared. We went down a power. When you divide by x, you go down a power. So this was, and maybe this will make more sense when I do the next thing. These coefficients, now instead of starting with x cubed, start with x squared. So that's 2x squared minus 3x plus 2. And that also has a funny name. It's a polynomial, but it's 1 degree less than what we started with. So you want to guess what its name is? Depressed polynomial. Well, it's not more depressed than the coefficients, so it's equally depressed, but it's not coefficients, it's now a polynomial. So that's the depressed polynomial.
I get like, Mr. Wolf, all this is depressing.
Fair enough. And more good news, I guess, if r is 0, like it was for this, the depressed polynomial, like the new polynomial that's 1 less in power, is also a factor. And that's our answer to the division question. So if you jump all the way down, we didn't need all that space. 2x cubed minus 5x squared plus 5x minus 2 divided by x minus 1 equals that depressed polynomial. 2x squared minus 3x plus 2.
If x minus 1 is a factor and like the depressed polynomial is a factor, does that mean like you multiply to get that thing?
Exactly right. In fact, I was just thinking about writing that, and I was like, I don't know if that helps or not, but since Kinley made the observation, let's write it. Let's write it this way. That means that our original polynomial is equal to, if we multiply the two factors. Maybe we back up to our, that one didn't work. Let's see, what's an easier one? 24 is 8 times 3. Like, they're both factors, so 8 times 3 is 24. Same thing here. If we multiply our two factors, we would get our original polynomial. So in some ways, this occasionally can help us with factoring. But you kind of have to know where to start, because otherwise you're just guessing. Kim, did that answer your question?
Yeah.
And all of this one is nice because the remainder is 0. If the remainder is 0, you found a factor, the depressed polynomial is a factor, everything's nice, you don't have to worry about the remainder. Having said that, the remainder is not always 0. Okay, before we get to the boxes, maybe we should say, let's back up in our brains a little bit. If x minus a is a factor, then what does that, I guess we could put arrows going either way. If x minus a is a factor, then what does that mean is the root or the solution? So you would set your factor equal to 0, and you'd get x equals a. So x equals a would be a root or a solution. or a 0. Call it any of those things. Oops. Root, solution, solution. Root, solution, 0. Those mean all the same thing.
I thought that was going to be the solution to my problem.
If it's a 0, that means that f of a equals 0. We call it a 0 because on the graph, like whatever else is going on, that would be at 0. The function at a is 0. Okay, that we kind of already know. In fact, that first two stuff, you did that however many solve problems were on that test Wednesday, you did it that many times. You set your factors equal to 0, and you found your roots, your solutions, your zeros. Okay, this is using that same idea. The factor theorem sounds fancy, but it's a fancy way of saying everything we just said. The binomial x minus a is a factor of the polynomial if and only if f of a is 0. You remember what if and only if means from your geometry? Means like you could go either direction with it. So that's why I put those bidirectional arrows on there. If x minus a is a factor, then f of a equals 0. If f of a equals 0, then x minus a is a factor. Those always can go together. Okay, here's kind of the weird thing that people especially try to read this. The remainder theorem. I guess I'll read it and then try to put it in better words than this. The remainder, so we synthetic divide, we get that last number at the end by itself, that's the remainder. When you divide a polynomial by x minus a, is f of a. That's all this other stuff probably doesn't need to be said. The remainder is f of a. Yeah, the rest of this stuff is more complicated than it's worth. The remainder is f of a. That's what the remainder theorem says. If you synthetic divide with a, whatever you get for your remainder is the function at that value of a. Okay, we'll use that more in a minute. Example, show that x plus 5 is a factor. Okay, if it is a factor, then what should be true? If x plus 5 is a factor. I should get a remainder of 0. That should be true. And then find the remaining factors of the polynomial. Okay, so we'll get if that one works, we'll get a depressed polynomial, and then we'll have to factor the depressed polynomial. So start with the coefficients. 1, 2, negative 13, 10. And we'll synthetic divide with, here's the first trick.
Minus 5.
Good, with negative 5. Because if x plus 5 is a factor, then x equals negative 5 is the number we'll use out front to synthetic divide. How do we get started? For a synthetic divide problem? Careful, don't divide, just bring the 1 down. But multiplying is where people go wrong. So like, you do a bunch of these and your brain just starts, oh yeah, multiply, divide, multiply, divide, multiply, divide. But don't do that to start. You got to just bring the 1 down to get started. Then you can multiply, divide, multiply, divide, multiply, divide. Brooklyn, you're looking at me like, oh, I'm sorry, yeah, multiply, add. No wonder you're looking at me crazy, because I'm saying something crazy. Multiply, and then add. Yes, I don't know why we would, you're right. So add, we would get negative 3. Why don't you see if you can finish that one off? And because they kind of told us already, we know what our remainder should be. So you kind of a built-in check on this problem.
Wait, I have a quick question.
Yes, sir?
For the next one, you just multiply it by 5. Negative 5.
Well, you're going to do negative 5 times negative 3.
Yeah.
So that gets you 15. And then add 2. Multiply. We get negative 10. Add, we get 0. Which we were expecting because they told us, when they said show that x plus 5 is a factor, that how we'd show that is by finding that r equals 0. So yes, x plus 5 is a factor. And now we have a depressed polynomial. What's that first x squared? I didn't even know how to ask it. You knew what I was going for. How did you know it was x squared, Ben?
Because it's 1 and like it's x squared. It's ABC. Basically.
Okay. But how did you know it was x squared rather than x cubed or x to the 4th? How did you know to start at x squared? Because we won't always start at x squared.
I low-key don't know.
Okay.
I said x squared.
Okay. Brooklyn?
1 degree less.
It's 1 degree less than what we started with. Right? That's why it's depressed, because it's 1 lower than. And we started with x cubed. If we started with x cubed, then this one's going to be 1x squared. Minus 3x plus 2, and then the remainder. By the way, there's another way to figure that out. This one's always the remainder, the last one. So you can also count up. The next one over is the constant. The next one over is the x, and then the x squared. So you kind of have a built-in check. You can start at the right end and work your way over. Remainder, constant, x squared. Wait, I did that backwards from your perspective. Or you can know that the highest power is 1 less than what you started with. Usually you kind of do both and make sure that it works out.
So you're essentially just removing all the x's, like just one x, not all of it, but like one x.
Yeah, it dropped by 1 power. It's depressed. It went lower by 1 power.
Man. Oh, no.
Okay, so this polynomial can be factored as, we know x plus 5 works. But that means the other factor is the depressed polynomial. That depressed polynomial, x squared minus 3x plus 2. I hope you did this a bunch on Wednesday. Can be factored again, right? There's quite a few of those problems that were multiple step. So I can factor that 1 step further. Let's see, 2 and 1, minus 2 minus 1. Which means, this is a lot of words for, we can just factor this all the way now, x plus 5, x minus 2, and x minus 1. Okay, that's the factor theorem. If you get a remainder of 0, then what you divided by is a factor. And the leftovers are a factor, and maybe you can factor them further. So I hope you did okay on the factoring part of the test yesterday, because we're still factoring. Okay, last example, by the remainder theorem, f of negative 2 is the remainder when you divide the polynomial by x plus 2. This is kind of weird. In fact, let's back up. I don't know what r is. We'll get to that in a minute. What? Should have done this to begin with. If I ask you to find f of negative 2, forget all this factor, remainder, synthetic division stuff. What would you do to find f of negative 2? Plug it in. And that still works. But your reaction of, oh gosh, is right, because nobody wants to do this. Right? Like, I mean, it's not wrong, but like, I don't want to sit there and do negative 2 to the 4th and then multiply by 3.
This is where you present a solution to that problem.
I am going to present a solution to that problem. I'm going to present an alternative method to find the solution. So that would work. And there are students who do that to like check their work. Like you do it the way I want you to do it. And then if you have time, knock yourself out. We should get the same thing. The remainder theorem says that when I divide, the remainder should also give me the answer. And finding the remainder using synthetic division, I think, is easier than this. Because synthetic division is just multiply, add, multiply, add, multiply, add. Way easier than this stuff. So let's set up this problem. Grab the coefficients. Okay, here's the tricky part. What number is going to go out front? Yeah, f of negative 2. So we kind of go the long way around to get there. If negative 2 is the answer, then x plus 2 was the factor, which means negative 2 is what we'll use to synthetic divide with. And whatever we get for the remainder is f of negative 2. So I hadn't even done it yet, but I know that whatever lands in that box will be my answer. How do I get started on a synthetic divide problem? Bring down the 3. And then I'm going to let you finish that one off. Multiply, add, multiply, add, multiply, add, multiply, add until you get to the end. Here it is right here. 2 minus 6. Not to pick on Max, but the trouble with these is if you make one small mistake early on, right, it just carries through and then you mess up the problem. So please be careful while you're multiplying and adding. I shouldn't pick on Max, but almost everybody does it at some point. And you make one mistake right here, and then that obviously messes up the rest of the problem. So be careful while you're multiplying and adding. See if I can talk and do this without messing this up. I got 8?
Yes.
Is that what y'all got? Okay. That means f of negative 2 is 8. And if you don't believe me, you can go do this the long way. And if what I'm claiming is right, you'll get 8. But this, even with the multiply add stuff, is faster, I think, safer, easier than fourths and cubes and squares. It wouldn't be terrible with 2's, but if I ask you to find f of 4 or f of 5, that would really get ugly in a hurry. Doing it the plug-in way. Doing it this way, even with 4's and 5's, wouldn't be terrible. You'd just be multiplying by 4 or 5 and adding, and it wouldn't be too bad. So the remainder is 8, which means f of negative 2 equals 8. Let me summarize the new stuff, because there's 2 new things going on here. 3 new things, maybe. There's a new process. That's synthetic division. That's the house. Bring down the first one, multiply, add, multiply, add, multiply, add. That's not too bad. But then there's also new, like, what do I do with my answers? Theorems, theory, results, trying to figure out what to call this. Application, maybe. Like, how do I use that? If r equals 0, then x minus a is a factor. And then the second thing is f of a equals the remainder. or it might be better to even phrase that the other way around. Whatever you get for the remainder tells you f of a. So today's kind of tricky because I feel like most days we either learn some new theory about stuff we know, or we learn a new process to do. Today we're doing both. So the new process, which isn't that hard, the application is really not that hard either, but throwing it all in one day is maybe what confuses us. Okay, today's assignment is this worksheet 5-2A, the next worksheet. And we need to do a couple of these together because there's a sneaky thing about some of these that we hadn't hit yet. Okay, I guess we should read the directions. Show whether the binomial is a factor of the polynomial using synthetic division. So what would I be looking for? What will be true if x plus 4 is a factor of this thing? R equals 0. So A is a fancy way of saying, does R equal 0? Because if R equals 0, it's a factor. If the binomial is a factor, meaning if R equals 0, then factor it completely. So keep factoring. That's what we were just finished doing. We're good with that. If the binomial is not a factor, what does that mean for the function? Well, it means the remainder is equal to f of whatever a was. That's worded kind of weird. So let's do 1 and 3, because one of these will work and one of these will not. So we'll see what to do for part B. Okay, we're synthetic dividing on all of them, though. So 1, -1, -20. And this is why I wanted to do this one. I need all my coefficients there. But it feels like I'm missing something out here at the end. The constant term isn't there. It's not there because what is it? 0. So I've got to fill in all of the spots. So be careful about missing terms.
Wait, so if there's like an x squared and then an x to the 4th, you have to put like 0 for the x cubed stuff?
Exactly right. I'm looking for an example of that. Number 9 has an example of that. So my coefficients for number 9, let's just write down the coefficients real quick. Going out of order, but. So the first coefficient's 1. My coefficient of x cubed is 1. What's the next coefficient going to be? It's not -37.
Oh, yeah.
It's 0, because there's an x squared term that I have to account for. So that is definitely what will get people on the test, is that missing term. They're so locked in on what to do, they forget to be careful about the missing term. Okay, back to number 1. It had a missing term, but it was at the end, and so that's kind of not as big a deal as the missing term in the middle. What number should I put out front? -4. How do I get started? Bring down the 1. And then multiply, add, multiply, add, multiply, add. Carefully, though, not fast, Max. I shouldn't pick on Max. I almost made the mistake here. Yeah. So what does that mean? I got 0 for the remainder. The remainder is 0. What does that tell me about x plus 4? X plus 4 is a factor. And it tells me that my leftovers, my depressed coefficients, or my depressed polynomial is a factor. What term is that first one? X squared. I usually start at the left end because I want to go that way, but other people will start at the right because it's constant and then x and then x squared. Either way. Okay. Okay, I need to go back and check my directions here. Part A, show whether the binomial is a factor. So I need to say x plus 4 is a factor. So every one of these is going to say is a factor or is not a factor. And then part B is if it is a factor, then factor it the rest of the way. Well, that's pretty easy. I can factor an x out of that. If it feels weird to put it there, it's fine to put it in front, but either way. So there's part B, fully factored. Haley? The minus 5x? So I knew this one was x squared, and then I just start counting down from there. So that one's x squared, that one's x, and that one's a constant, so I just left it off. Number 3. 1, -1, -10, 0. Don't forget about the 0. What number is going to go out front? -2. So bring down the 1. Multiply, add, multiply, add, multiply, add. Carefully. What does that mean? I got an 8 for a remainder. Oh, I heard both answers that I wanted to hear, actually. The first answer, like question A, is what does that tell me about x plus 2? Not a factor. But then what does it tell me about f of -2? That's what somebody was saying. What's f of -2 equal to? 8. Okay, so every problem you're going to synthetic divide, your first conclusion is it is or is not a factor. And if it is a factor, well then keep factoring. If it's not a factor, then you state that f of -2 equals 8. And so now we're done with number 3. So 14 problems, but man, they go pretty quick once you get the hang of synthetic division. Do we want to jump over and do number 9 since it had the missing term and just like bigger numbers and see what happens on that one? Seven goes into 84. I don't know if that's going to matter to us or not. Bring down the 1. Multiply. Add. Multiply. Got to know your multiplication tables here. Add. Multiply. 12 times 7. In theory, you should know that. If you don't, you come out to this side and you figure it out. That's 84. In fact, it's -84. My remainder is 0. What does that tell me about x plus 7?
Which is a factor.
X plus 7 is a factor. So x plus 7 times, what's the first term? I'm trying to figure out how to say it. X squared. Because we started with x cubed, we depressed it by 1, so now we're at x squared. Again, if you don't like that, you start at the other end, and that means 12 is the constant and 7 is the x term, and build your way up to x squared. If you ever get it where they don't meet up, it's probably because you left out a 0. And so if they check both ends, like check from one end, check from the other, and it doesn't match up, it's probably because you left out a term. Okay, it is a factor. That means we're supposed to keep factoring. Oh, that's a nice one, I think. 3 and 4. me do another one while we're still here.
What happens if it's not a factor?
If it's not a factor, then you can't factor any further because that means the rest of it's not a factor either.
So do you just leave it like that? Like
Your statement B, I mean, this is still true, f of negative 7 equals 0. That's true, but we want to factor further. If it's not a factor, you would say this and be done.
all right, thank you.
Mm-hmm. 13 because it looks ugly. Oh, there's a 2 on the... So let's be careful about not missing any of the terms. They're all there. What number goes out front? Negative 4. Bring down the 2. Multiply. Add. Uh-oh, getting big numbers here. Do that right? 2 times negative 4 is negative 8. Yep. 4 times 18 is 36 plus 36 is 72. 72 plus 3 is 75. But if you're going to multiply a big number by 4, 75 is not a bad one. 75 times 4? What's 75 times 2? So double it. 150. And then double that, 300. So negative 300. So negative 288.
Definitely not.
Definitely not a factor. But then what else do we want to say? That's statement A, x plus 4 is not a factor.
We say that x plus 4 is equal to f of a.
Careful, f of 4. Or f of negative 4, excuse me, is negative 288. And those were big numbers, but it still would have been better than doing 2 times negative 4 cubed minus 10 times negative 4 squared. I mean, it's doable, and you would have gotten negative 288, but synthetic division is faster. Okay, so your job is the rest of those. It's a lot of practice, but hey, it's a long weekend, and I don't think it's too challenging. Maybe you can find time the rest of the day to squeeze